1
Okay.
second.
Okay, Lukas is the founder at bridgedirectory.com, and he will hold the building data bridge search in.
Do you see my slides? Everything okay? Okay, 1 second. Okay. Do you see my slides when I change them? Hello?
Yeah. It's okay.
Everything okay. Okay, very nice. 1 second. Yeah, so after a little bit of a delay, I guess we can start if everyone's here. So nice to see everyone here. Nice to see everyone in Data Science Conference Europe. I hope you've enjoyed previous presentations if you watched them, and I hope you will enjoy this one as well. So my presentation is titled, as you can already tell, Building Data Research Engines with MariaDB. And I am going to go through the things you need to know if you are considering maybe building a data research engine or something around that realm in MariaDB or with MariaDB. So I will I will do a short introduction of myself, and then we can start. So first thing is I wrote a book called Hacking MySQL, Breaking, Optimizing, and Securing MySQL for Your Use Case, which is a big part of what this workshop consists of. I will also showcase some stuff in the book when explaining stuff in other parts of the workshop, aside from the slides. And aside from that, I run a data research engine at bridgedirectory.com for those who didn't know, and as already was mentioned, I partnered together with MariaDB, and I was working at several nines representing the MySQL staff a couple of years ago. I work with a couple of companies who do database things, so DB Visualizer, Archetype, who is now a part of ClickHouse, Redgate, and others. And I also very frequently speak at conferences, and you can find ways to contact me on my website, or you can reach me via Twitter on the bottom right side of this window. So for the agenda for today, what we have is we are going to go through what is a data breach, what are data research engines, what database you should choose when building a data research engine, what options you have, and what options you have as far as NoSQL and SQL contexts go. What's the role of MySQL and MariaDB? How does MariaDB for bigger data sets look like? How does using MariaDB for your specific use case for bigger data sets might look like? How it might look like when building data research engines. And we're going to go through a couple of things you should know as well and summarize everything. And also at the end, you will see a quick demo. So before we begin, we should probably start from the bottom, right? So if you're building a data research engine, you should probably understand what a data breach is and what it consists of and what you can expect when working with this data, right? So data breaches is something that's often very misunderstood by many people. Data research engines for that matter as well, because people think the data research engines are something related to maybe CVEs, maybe pen testing, maybe something around that realm, but they rarely think the data research engines actually let you search through leaked data breach data, which is what they do. So data research engines and data breaches in general, they are basically illicit access. Data breaches are illicit accesses to data that is stored in a system, obviously. So hackers access the data, that is a data breach. After the data breach happens, the data most likely will get leaked on some sort of a forum, on some sort of a website, and there are people that basically collect that leaked data and build data breach search engines. This is sort of a very high level overview. So as far as database search engines go, they have usually billions of rows within their database, within their reserve, so to say. The ways they search through data directly depend on database structure and internal details. We're going to go through that as well. Some of them provide other search results as some of them provide different search results than others do. And all of them operate sort of some of them operate in some of the gray areas of ethics, let's say. Some of them operate in more, let's say, white areas of ethics, because not all search engines are built the same. Search engines, especially based on data breach data, they can very easily cross the line, so you have to keep in mind ethics and legality as well. So I'm going to go explaining a little bit more in detail as we go along. So my own data breach search engine is located at breachdirectory.com, as was already mentioned, as I already told you. And this looks like so. This is one page within the data breach search engine, which is the search page. And as you can see, it has a wide variety of different things on the page, and each of those things have something to do with the database. Each of those things have something to do with the database because each of those things are derived from the database or derived from an application themselves. So before building a data breach search engine, before building out the structure, the database structure, right? You have to understand how your application will be used and how your application looks like from the user perspective. And from then you can start building your application. So as far as options go, there's no shortage of them. So majority of people actually that you will tell I'm building a data research engine, building something on big data, will suggest you go through NoSQL based database management systems. But for data research engines, these aren't exactly ideal, and I will tell you why in a second. You should be looking at relational database management systems, such as MySQL, Percona Server, or MariaDB, which is one kind of all a part of one puzzle, so to say. MySQL will make your databases ACID compliant, which is basically 4 sets of database properties that guarantee data integrity despite any kind of errors, mistakes on your part. Let's, for example, say you're inserting data and electricity goes out, so your data will still be intact, and so on. NoSQL databases, on the other hand, they have very wide variety of choices to choose from, as do relational databases. You can choose MongoDB, Elasticsearch, Redis, or DynamoDB, or anything like that. And NoSQL will usually support base functionality, which means that in essence, base means that your data will be basically available and eventually consistent, which is what it in essence means. What this means is that your data may or may not be consistent, but it will be available. ACID will, in essence, guarantee that your data will be consistent, isolated if necessary, and durable, but base, it works the other way around. So if you choose NoSQL, you will be choosing base principles, and each of those principles may be implemented differently based on the database management system you are using and you choose to use. We are using MariaDB for this example. So ACID and MariaDB, it looks like something like this. So it means that atomicity is ensured by ensuring that all statements in a transaction operate as an indivisible unit and they cannot be overcome. Consistency means that MariaDB has a logging mechanism, which I will also walk you through in the workshop part of this tutorial, that records all of the changes to the database, and log files are usually scanned through when you are recovering your database from a backup, from a crash. Isolation refers to row level locking, which means that certain rows will not be able to be accessed during some sort of process. I'll walk you through that in a second as well. And durability comes down to log files. All right, so after you understand that, it's time maybe probably to understand how everything works with big data concepts, right? So atomicity probably means that all of your data will get imported and nothing will get lost. Consistency will mean that all changes you make to the database will be recorded in the log files. Isolation means that you will be able to use shared and exclusive locks within the storage engine that you use. Most likely you're going to be using InnoDB. I'll explain why in a moment. And durability means that your backups will be able to be recovered. So those two things are very crucial to understand for data breaches because when you are building a data breach search engine, when you're working with it, you will choose either one or the other. It's most likely not going to be both, and it's most likely going to be either SQL or NoSQL in both of your local instance, let's say, and your live website instance or application instance. So you have to understand your database before building anything. So we're working with MariaDB. So what you have to understand is the following. The first thing is that MariaDB has a bunch of storage engines that you can work with. MariaDB is kind of unique in this regard because MariaDB has more database storage engines that you can choose from than MySQL does. Percona Server has a couple of extra storage engines that you can choose from as well. And regardless of what database management system you choose, you will have to make a choice. You will probably choose InnoDB as your primary storage engine of choice unless you have very good reasons for not doing that. If not, you will probably be using ExtraDB with Percona Server, and the rest of storage engines will be either used as part of you doing smaller tasks. For example, MySam will be useful if you want to count row counts in a table because it stores the internal row count in itself. InnoDB does not, but this is how it goes. And the next thing you need to be aware about is hashing and buffering. Hashing is actually very useful, especially when primary use case of your application or primary use case of yourself is a data breach search engine, because hashes can hold a lot of data inside of themselves. And in many cases, you can return data from the hash itself for your application to faster return data. The next thing you need to be aware of is you have a parser, optimizer, and SQL interface. Parsers and optimizers are something that your SQL query always goes through when SQL queries are executed. So each of them have their own, say, remits in your database, and each of them can be optimized differently. SQL interface means that you will probably be using some sort of an SQL client to interact at least with a part of your database. Maybe you're using PHP maybe you found yourself using archetype, let's say. Maybe you find yourself using the Beaver, DB visualizer. There's no shortage of them, but you will use some sort of an interface to interact with your database. The next thing you have to understand is that your database doesn't only consist of the database. The database is stored in a file system. So all data, indexes, logs, and other associated files will be stored in a file system, which means that they will be stored as types of files on the disk. Newer versions of MySQL are really generous in this regard because it stores data in one data file. It stores metadata from your tables in one data file, and the rest are split across different files. I'll explain why in a second. The last thing you need to be aware about is how you connect to your database in the first place. So you will have the connection pool, which will define how will you connect and using what will you connect to your database, using C, C++, Python, PHP, Java, whatever. Right, so as far as database search engines go, you will again need to come back to that, and you will need to consider each part of your application impacting the database, right? So for big data sets, what you have to consider is, first thing you have to consider, most likely one of the first things, is the type of queries you run when search queries are being executed. Because if your primary use case is a database search engine, your primary use case or one of your primary use cases will be searching through the database for something. And as a result, if you have a lot of data breaches inside of your system, you will have most likely to use some sort of a loop to loop through all of the tables and all of the data and to return results. So for most of you, things will be pretty simple and can be accomplished as simply as the result you will see on your screen right now. So what you see here is that you have a set of tables in a variable, and then you loop through them, putting them in another variable, and you put the results of that variable into your query so that your query, each time it loops through a different table with the same query. So search type means that search type is chosen by the user. So many database search engines, they not only allow you to search for one data type, let's say emails, they also allow you to search for other data types such as usernames, maybe something else. And you also need to consider that you may be using the limit clause for something. The limit clause is actually very useful for database search engines, especially because many of you will probably use it as part of limit one, for example, to just return one row because you only need to see if there's a hit in that specific table for the account that is searched for. So that is very useful. And if you need to return only one row from a specific data breach, this will be very, very, very fast, especially if your database is optimized. The next thing you need to do is to obtain results from the query that you just made, and you need to act on them accordingly. So this is very kind of a bird's eye view of what you need to do. Now, these things will only work if your database will be configured properly. So MySQL will have this file called my.cnf or my.ini if you use Windows. But regardless, this will consist of many different settings that you need to optimize to make your database management system work in a performant way. So you will see that the first thing you have is an error log, which means that basically this is the file that MySQL stores all of its errors in, and this will be the file that needs to be reviewed after certain errors occur. The default storage engine defines the primary and default storage engine used in MariaDB, which is InnoDB, and most likely you are not going to need to change that unless you're doing some maintenance tasks. File per table means that all tables using the InnoDB storage engine will be stored in a file specific to themselves. That means that InnoDB, the storage engine, will have one file that it stores metadata from the tables and databases in, and the rest of the tables in your databases will be stored as separate files. This is very important because earlier on, when this didn't exist, InnoDB only stored data in its data file, which was IBData1, as you can see over here. And this file was storing data, metadata, indexes, multi-version concurrency control data, and all other kinds of stuff, which meant that basically if you delete a table from your database, the data is still stored in IBData1. There's no way to get rid of it unless you delete IBData1 by itself, in which if you do, you delete all of the data existing in InnoDB. So this wasn't ideal. InnoDB, a file per table, solved this problem. The next thing you will need to be aware of is that you will also have a flush method. A flush method will describe, in essence, how your how data is written to the disk. So for Windows users, you will be most likely using normal or fsync option. For Linux users, you will most likely going to be using odirect. And what this means is just a flag that lets your operating system know whether you want the operating system to bypass the operating system's hash when inserting data. odirect does that. So this is why it's recommended for performance reasons. InnoDB data file path, it defines the data file, which as I already told you, stores all of the data regarding InnoDB, its size, whether it extends automatically, and what's its maximum size. So the data file, the default data file from the storage engine will always be called IBData1. It's just the name. And by default, its size is 12 megabytes. But obviously, if you run something bigger, if you run big data sets, you will need to make it a little bit bigger. So what you need to do is you can set it to extend automatically, as you can see here on the 6th line, and then you can define the maximum size. And here I define the maximum size of this file to be 100 gigabytes, which means that the data file can extend to a maximum size of 100 gigabytes. And if it does, MariaDB will return an error, and you will need to increase this size and restart MariaDB for it to work properly again. This is important because if you don't have your maximum size set, if you run out of disk space as a result of this file expanding and expanding, you will have some problems. So this is very recommended you will do it this way. I would also like to note that 100 gigabytes for the data file, which is IBData1, is very much overkill, at least for these days. You will most likely be okay with 20, maybe 30 gigabytes, depending on how much data you have, but 100 gigabytes is most likely not going to be necessary, especially when the primary file stores only metadata related to the tables and not the data itself. The 7th line defines the buffer pool size. Well, the buffer pool is basically the most important parameter in InnoDB, which means that this means that how much operating memory are you allocating to MariaDB or MySQL. This means that setting this to 16 gigabytes essentially means that you want InnoDB to be able to use up to 16 gigabytes of available memory on your server. The reason why you set this to exactly 16 gigabytes is probably because this system had around 24 gigabytes maybe of RAM, and a good starting point when fiddling with this option would be to set it to 60 to 80%, from 60 to 80% of available RAM in your system. The log file size, it's usually a quarter of the buffer pool size. You can set it to another size, but it's usually a good ballpark to be playing with. And the log files will only need to be scanned through when your database is being restored from a database backup. Log buffer size, the same goes for that. And InnoDB flush log a transaction commit. It maybe seem a little bit dubious for some of you, but what it essentially means is that you set the way MariaDB and your database acts when inserting data, when working with data. So 1, which is the default option that you see on line 10 here, is means that your database will always be ACID compliant, which is the principles that I just talked about. There is 2 other options. You can either set this to 0 or to 2, which means that in essence, your insert operations will become a little bit faster, but at the expense of if you inadvertently shut down the database. For example, if your electricity goes out, you may be able to lose up to 1 second's worth of transactions. So this is not recommended to set different options than one. One option, as I said, ensures ACID compliance, and it, in essence, is the recommended option no matter what your use case is. And unless you have very good reasons to change that, and unless your all performance optimizations fail, you shouldn't be touching that. You will also have, depending on what kind of operating system you're using, a bunch of other options, such as, for example, DB lock void timeout. And what this does, it's not a major option regarding InnoDB, but what this does is it tells your database storage engine how many seconds it will wait before considering a row to be timed out once it's locked. Again, this considers a bunch of, let's say, corner use cases that may be necessary, but you didn't really think through. So for the rest, you will need to turn to documentation. But the most important parameters will be the log error, which is the log file, the default storage engine, which is most likely going to be InnoDB, file per table, flush method, data file path, buffer pool size, log file size, log buffer size, and flush log a transaction commit, as you can see on the screen. So when optimizing these parameters, you will also have to keep in mind that you will always have to think about your database when building your application, right? So for example, for me, a database search engine looks like you see on the screen right now. And you always need to be aware about how each of those parts interact with your database. So starting from the top, for example, you see that there is some sort of records from some data breaches, right? So that means that you count something in the database. Again, you need to count the amount of data breaches in the database. So you need to count something again. There's a last update time, which obviously is taken from somewhere. So if you take this from a database, you always have to account for that. This won't be a problem for most of you, but you always have to keep that in mind. If you want to record the amount of searches that are being made through your search engine, you can also do that, but you again need to account for that, and you need to account that InnoDB, which is the primary storage engine, as I already told you, doesn't really store the row count internally. Only MySAM does, which is basically means that if you want to do something like that, you may be considering using some sort of MySAM based table. MySAM is a storage engine, and putting, let's say, some records, some MD5 hashed records into that database and counting them after every search is made or something like that, depending on how you do that. And you will also see that you will have a bunch of search types to choose from. You can search for emails, usernames, IP addresses, or website domains or website titles. All of this is meant to narrow down the search query, which means that the search query is able to access little rows, as few rows as possible, and this makes it fast, right? So no matter what kind of search query you will be providing, as you will also as it is necessary to do, if you have something that necessitates filtering down the amount of accessible rows that are provided by your database, is always a good idea to do so. The next step would also be considering whether you will have some exotic search methods available for you to use. So many database search engines will not have that, and many search engines in general will not have that. But if you want to, you can have wildcard search methods and regex search methods. And what those methods will do is it will essentially allow your users to search for something in the database with fuzzy matching. So they can, for example, provide a regex expression and then get results returned to them, which is something you may be considering. If it's a data breach search engine, you will most likely going to be considering notifying users when they're in a data breach, right? So you will have to account for that as well. And obviously, one more thing that you need to be accounting for is the results, which you can see here. Your account is at risk of identity theft. This is a result of a search being made and the results being returned. So depending on how you return results, depending on how many results are scanned through, it depends the speed of the query. The speed of the query depends on that, right? And depending on what kind of results you need to return, you will also need to be aware of the consequences for your database in regard to that, right? You also need to consider that no one use case is the same. Each database search engine or each application in general is pretty different. Your application may be different from my application. My application might be different from what you hear, what you read about in the documentation, right? Your database management system may be different from what other people choose. So if I choose, for example, MariaDB and other people choose Percona server, this is also going to be different. You will also be dealing with different people using your application, no matter whether you're building a data breach search engine or something, anything other than that, right? And so you need to account for that, and you also need to account for your queries being run. And one of the primary things you need to be accountable for when queries are being run is the speed. So speed and performance, database performance in general, is a very big problem for database administrators and programmers and developers alike. And the reason why is because they fail to understand that queries are usually tasks. Queries are usually tasks that have subtasks inside of them. So what I mean by this, in other words, is that each time you run a query, that query has to go through a couple of different steps to complete. What you see on the screen right now is the steps that your query goes through when you run, for example, an insert query. I think it was here. So you can see here that your query has to start, check for permissions, open tables, initialize, update, query end, close tables, free items, and clean up. So that's 11 steps you have to consider. Each of those steps will have certain overhead, will have certain duration associated with them. And since you're not running a singular query, since you're most likely running tens of millions or maybe hundreds of millions or even billions of queries, because you need to insert hundreds of millions of rows, you will also need to be aware about that, aware of the fact that each of those queries will also go through these steps, right? Which means that each of those queries will also have, will take time to complete. And if you run 100 million queries, what you need to do is you take this duration for one query that you see on the screen, you sum these durations up, you have some sort of a number, let's say a millisecond or 2 milliseconds or whatever, and then you times that by 100 million times because you're inserting 100 million rows, for example. And this will give you a good ballpark of what you can expect in terms of how soon will your query complete. We will go through a couple of performance optimization tips in the workshop of part of this tutorial, but when starting to optimize any kind of queries, you will need to be aware of that. Otherwise, you are going to drown, to say it like that. And as far as performance optimization goes, you will have a couple of options. For most of you, it will be related to indexes because indexes make select query performance faster because they make select queries able to access less rows than usual, and so they're that much faster. So one misconception regarding indexes in database management systems, and especially in MySQL, MariaDB in general, is that MariaDB has a bunch of indexes that you can choose from. It has covering, composite, cluster, descending, full text, unique, hash, and primary key indexes, and all of that jazz. But in general, indexes can be split into two categories, not into 10 or 11 categories, as some like to say. So indexes can be split into two categories, which are B-tree indexes, which consist of many index types, all index types except for the spatial index type, and R-tree indexes, which is the spatial index. This means that, in essence, whatever index you choose, if it's not going to be a spatial index, it is going to be a B-tree index. And this means that you will also need to consider a B-tree part of an indexing, for example, documentation, right? So if you're looking at the documentation, now you will not be looking at the general indexing documentation, but maybe at the B-tree index documentation. And if you know what kind of index you're using exactly, I'm going to be walking you through that in a second as well, you will be able to also go through specific use cases for that kind of index as well. So covering indexes mean that, in essence, they cover all of the columns required for the query to execute. Composite or clustered composite indexes or multi-column indexes mean that there's one index and multiple columns. Clustered indexes relate to the primary key within MySQL or MariaDB or Percona Server. Descending indexes mean that the rows inside of them are stored in a descending fashion, so from 10 to 1, in the descending fashion from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So not ascending, descending. Full text indexes have their own limits as well. So full text indexes will be necessary if you find yourself necessitating, for example, wildcard searches that are available within full text indexes. Unique indexes mean that, in essence, the data inside of that column that has unique indexes on them will be unique. That means that it will have no duplicates. Hash indexes are specific to one kind of storage engine, which is the memory storage engine. And primary keys, they are, in essence, clustered indexes. They're the same thing. Primary keys, what they do is they make your database able to automatically increment numbers of IDs when null values are inserted. This is usually very useful when you have ID columns. So if you have ID columns and then something else, some other columns, you will usually insert null values into those columns that have a primary key index on top of them, and you will be able to have automatically incrementing IDs. And then, if necessary, you will have, for example, an ability to select the last ID that was inserted into a specific table and have a specific ID and work on that if necessary. Spatial indexes or R-tree indexes will only be necessary if you work with geographic data, so geospatial data, which is why it's called spatial indexes. In most cases, if you're building search engines, and especially database search engines, these things will not be necessary. In most cases, you will be working with clustered indexes, covering indexes, perhaps composite indexes, perhaps unique indexes, full text indexes, and that's kind of it. And that depends on your use case as well. So what you see on your screen right now is ways that your database uses the index to find specific rows, right? Ways that this defines the steps that your database takes to find a specific row that it searches for. So, for example, when a search is made within your database search engine or within any kind of other search engine that you have, your application, it inquires the database with a query that you define in an application that I showed you. Maybe you use a loop, maybe you use something else. And then that query goes through connects to a table, and then that table, that query, asks your database, can we use a covering index? Which means that, in essence, can we read rows from the index instead of from the database? And if a covering index is defined, and if it's defined properly, I will tell you what it is in a second, the database says yes, and then it decides what covering index can be used. If there are multiple covering indexes, they will choose, MySQL usually chooses a covering index with the best column structure. A covering index, as I already told you, is an index that, in essence, contains, that can be scanned through instead of your database scanning the disk. And as a result of that, your queries will be significantly faster than usual. So for example, if you have a covering index named covering IDX on demo table, and you have ID and customer columns in it, as shown in this example, bottom row, first ornament to the left, it will satisfy, this kind of index will satisfy a specific kind of query that is provided by your application in this specific instance. And as a result, your database and your application will read data from the index instead of reading data from the disk. And as a result of that, your query will be significantly faster than usual. And obviously, query speed is not measured in kilometers per hour. It's measured usually in seconds or milliseconds, but I just added that for illustration purposes for you to better understand this. And if your database cannot use a covering index, your database will decide what kind of other index can it use. Maybe a full text index, maybe a B-tree index, maybe a vanilla index, maybe a primary key sometimes, if you're accessing an ID column. And if it doesn't have the ability to use any indexes at all, it will read the data from the disk, and as a result from your database reading the data from the disk, your query speed will be significantly reduced. Because as your query reads the data from the disk, it has a lot of things to consider, and indexes is not helping them. As a result, indexes help your query to quickly find rows by acting as a pointer to those rows. And in essence, if your database uses an index, it can make use of that pointer to that row to quickly find it. If it's not in place, you will have some problems. So there's a bunch of things that you need to consider when using indexes in database management systems in general. So those can be split into two separate categories. One category will be more important things, and another maybe less important things, but all of those needs to be considered, which is why you see two categories on the screen. So the first thing that you need to know is that covering indexes usually will be so much faster than other kinds of indexes, no matter what kind of indexes you define. The reason why is because, as I already told you, covering indexes will read data from the index instead of reading data from the disk. The second thing is that you can use indexes and partitions for your use case, no matter what that use case might be. If you use a data breach search engine, that might be very useful. If your use case is different, that may be less useful, but regardless, indexes and partitions is something that you should consider using, especially if indexes do not make your query as fast as you would hope they make. Another thing you will need to know is that you would need to index the column after the where clause. So why is this important? This is important because that way you are telling your database that you essentially are serious and you want the database to use the index. And there's something called the explain query. And in essence, it explains how your database accesses rows and what it does with them, and et cetera, et cetera. And as a result of that, you can refine your query to better make use of the index or partitions or whatever you have available in your database. The last thing you need to be aware about is to use the proper type of index. As I already told you, there's loads of types of indexes in MariaDB alone, and MariaDB doesn't actually prevent you from using multiple types of indexes on one column either. So you may be using covering indexes, B-tree indexes, descending indexes, and full text indexes in the same column. But no matter how many indexes you will use, MySQL will only choose the type of index that is available for your use case. That means that it will depend on your query. Another thing you need to consider is storage engines and my.cnf, which I already told you. You will be probably using InnoDB, which can be optimized via the configuration file, which we just went through. You will also need to consider data types and character sets, which is also a very important part of your database architecture, because if you have billions or millions or hundreds of millions of rows, each of those rows will come with a couple of bytes stored to the disk, right? So if you don't use proper data types or proper character sets, these bytes can quickly add up. So for example, one row can weigh, let's say, 40 kilobytes instead of 20 kilobytes, and then you have some problems. You also need to consider what columns are indexed and whether does indexing make sense for you as a person to begin with, right? Maybe you're just using partitioning, maybe you have other approaches, or maybe you don't even have enough data to necessitate indexing to begin with. So this is something that should be always top of mind as well. And a couple of outcomes that can be if you use indexes and if you use explain queries to explain those indexes, is that you will see using index condition, using a where clause, using file sort, or impossible where. These things, for context, are derived from an explain query type. When you run an explain query in front of, for example, select query, MySQL will return with a bunch of result sets that explain basically how it accesses rows and what it does with them. So these outcomes are a result of the explain query and the additional columns. So MySQL will try to explain how it accesses rows and what you can do to optimize access to those rows, but not many of you may be understanding that. So understanding the things that MySQL says, for example, here, using the index condition means that, in essence, MySQL usually used an index seek operation to retrieve matched rows from the disk, most likely. Using a where clause means that MySQL has used the where clause, columns in the where clause to access the data. Using a file sort operation means that, in essence, MySQL completed an additional file sort operation when accessing files on the disk, which in essence should be avoided if you want to your queries to complete as fast as possible, because as I said, each of those steps come with a couple of milliseconds of time that need to be accounted for. And you also need to have you can also have impossible where outcomes. This is actually very rare to have, and this happens once every 10,000 times, but this usually can also happen. What this means is that your query just doesn't make any sense for the database. So this happens when you have, for example, 1,000 rows in the table, and then you construct a query that says select a row 2047 from a table X, right? So your database just says that the row 2047 just doesn't exist, and this is why it returns an impossible where. Now, these things are not always written in the way that you as a developer would understand. So for example, as I said, right? So if your database has to wants to say that your query doesn't make any sense, it doesn't say your query doesn't make any sense. It says impossible where. So you have to interpret that. You have to know how to work with that. You'll have to know what it means in general. But the rest, you will have a bunch of other things to consider. But unfortunately we don't have enough time for in the slides to get around them all, but I will showcase the necessary elements in a second. So for those who are very interested in what I will showcase and how, you will benefit from my book titled Hacking MySQL, Breaking, Optimizing, and Securing MySQL for Your Use Case. In the book, I go through all of the things that I just told you and a bunch of other things. All of the things that I just told you and 1,000 times more, it can be found in the book as well. So the book consists of 4 parts. If you consider introduction as a part as well, it consists of 4 parts, but otherwise 3. It consists of breaking, optimizing, and securing parts for your database. It consists of how you broke your queries, how to optimize your storage engine schemas, data types, how to optimize MySQL for big data, indexing, and so on, and how to secure your database instance and work with big data sets and other things. It also has an appendix. An appendix is essentially bonus tips for you to understand how your database works and why your database works the way it does. So some of you may come across a concept called Schrodinger's tables, which is a concept where your database thinks that tables do exist, but they don't really exist, or the other way around. Some of you will also be aware of the fact that, as I said, that if you delete IBData1, all of your data in your database instances will be gone. So that's a concept as well. Indexes is also a very fun thing because, as I said, MySQL and MariaDB does not prevent you from having multiple indexes on the same column. You will have a query that breaks MySQL 5.7 as well. There would be a way to reliably use MySAM to count rows. I will go through that as well in the book, and APIs and stuff like that. So if you're interested, you can access my book at hackingmysql.com, and I will proceed to have a demo now. I'll see how much time do we have. We have, yeah, approximately 40 minutes, 30 minutes. So I think that it's enough time for a demo. So I will prepare a demo in a minute or two, and then we can proceed from there. If you have any questions, feel free to ask for now. And I will share my screen again in a moment. So thank you. So if you have any questions, please feel free to ask, and I will come back again in a moment to share with you a demo too. Right, so let me set up the demo. Right, so I think we can get cracking on the demo as well. So what I will do here is I will share my screen again, and I will walk you through the workshop part of this tutorial. So give me a second, and yeah. So what I will want to start with is your MySQL architecture as a whole. So before doing anything on MySQL, you will need to have a good understanding of the architecture that you work with. So I will use a drawing from my book here that is called Hacking MySQL. And if we scroll down to the architecture part here, you will see that you have a bunch of things that you need to consider when MySQL is working, right? So you will see here that you have the client, you have the server, your database server, and you have storage engines, as I already told you. So the client means plugins and connectors working with MariaDB or your database. Plugins and connectors working with MariaDB and your database means external, basically, things that connect to your server. And server itself, it has multiple things that you need to consider as well. So it has a thread handler, which handles all of the requests to the query hash and the queries themselves. So it has a query hash and has a parser, which also goes through the optimizer. And these two things are very important to understand when you optimize your queries as well, because many people think that queries are just, run them and then they complete and there's nothing you can do about that. But that's not the case. They all of them go through parsers and optimizers to complete. And these things can also be optimized. I'll walk you through how in a second. And the server, it acts on your storage engines as well. So most likely you're going to be using InnoDB, but if you're using any other storage engines, you will also need to be aware of the fact that or other storage engines have certain characteristics unique to themselves. So for example, MySAM will store the internal row count inside of the database. Other storage engines will not. And these things need to be accounted for as well. Another thing that you need to be aware of is that if you run a data research engine, I can showcase that on my data research engine. If you have a search page, you will most likely have something that protects the search engine. So for example, if you search for an account when searching, if you're at risk, so we can use a test account here, you'll see that a response is returned. Your account was found. Your account was found in this data breach, this data breach, this data breach, and it impacted this many people. But what you don't see is that this also has a couple of protection mechanisms that you can employ if necessary. What I mean by this is that this will usually have some sort of tokens hidden within the code. So you can see that you have a hidden input field with the name of token, and it has a certain value unique to itself. What this is if we unhide it, if we unhide it, you can see that there's a token. It's called that way. It's an MD5 hash, and this MD5 hash is changing all the time. And this MD5 hash, it protects the website, the application, from cross-site Lukas forgery attacks. So for example, if you want to issue a request to this website through another application or through another website, you will also, together with the request, you will also need to send this token, which, as I said, changes all the time. And so it will be impossible to mount these kinds of attacks on the website itself. This is done via a firewall, which is also a very important thing for your database and for your application to consider, especially if you use data research engine. So I'll probably start with cross-site Lukas forgery that I already talked about. So these tokens are generated by a bunch of random bytes. So in PHP, it can be done with OpenSSL random pseudo bytes, and then you define how many bytes you need to generate and hash all of those things with MD5. And when your token is generated, it's basically put in a session variable called token or something else, whatever you want to call it. And then as it's generated, it also has to be checked. So you use another function to check the token, as you can see here. And you say that if the token in the session is the same as the token in the form or in your application or in your whatever space you want to use the token in, you in essence unset the token, you destroy the token, and then you continue as usual. This is important because if the token doesn't change, there's no cross-site forgery protection. So if you, for example, refresh the page here, if you go through, if you go for another candle here, you'll also see that the same token is in place, but now it's different, right? So it's 807 and this is 608. So this is completely different and there's no way to predict that. And this is what the OpenSSL random pseudobytes does. So in essence, if this is changed, if this token is changed, then what you do is you, in essence, terminate the connection or do something else or log the request or whatever. What this does is just dies and terminates the whole connection with the warning sign of cross-site Lukas forgery. Another thing you need to consider when building data research engines is that you will be probably attacked by SQL injection attacks, as almost always happens in web applications. So what you can do is most firewalls that protect from, for example, SQL injection attacks, they work in this way, right? So they have some sort of keywords that they protect from. So in this case, that you have insert, selective, date, and delete. So the CRUD keywords as they're known, and they basically scan each request. So get request and post request in this case. And if any of those keywords is in those get or post requests, as you can see here, the request gets basically blocked. Another thing that you need to consider is that you need those things to be case insensitive. So for example, PHP has this thing called stripos, which is a function basically that finds a needle in a haystack without accounting for insensitivity or case sensitivity. So what this means is find the needle in the haystack, case insensitive, what does the I stand for, this what it does, and in essence block the request if it's necessary. Here you can also log the request before blocking it or do some other things. As far as your database is concerned, you also need to have an understanding of the types of queries that you're running. So these things, or the types of the firewalls and the protections from SQL injection and cross-site request forgery and other attacks will only be effective if you are running an application and if you're running a data research engine in the first place. So if you do, you're most likely running some sort of queries that you execute. So that the most present types of queries would be create, insert, update, and delete. And I will walk you through them in a second. So these things, right? So these things might seem few and far between, but if you consider queries apart from the select, update, insert, and delete from the basics, you will also need to be aware of how queries work internally. So how queries work internally depends on the types of queries that you run. So as you can see, there is a bunch of different languages that you need to account for. So most likely the first is going to be for you DDL, which is alter, create, drop, rename, and truncate. The second would be data manipulation language, which is essentially what you use when modifying data or working with data inside of your database instance. So you can delete rows, insert rows, load data in file or something like that. Load data in file is actually very useful when you're dealing with bigger data sets because it essentially skips all of the overhead concerning insert queries. replace, it essentially replaces one thing with the other. Select obviously selects rows, updates. Union, it can be useful when you're joining one query with the other, and also the with clause. You also need to be aware of security within your database instance, and that can be done via basic data control language statements such as grant and revoke. What these statements do is probably you're already aware of it, but these statements, in essence, they either grant or revoke certain privileges. And also you will come across such statements as commit and rollback, which in essence mean that save changes in the database or delete changes from the database. And this is especially useful when you have a lot of insert queries that you work with. I will explain why in a second. So for example, if you see here I explained how indexes work, and somewhere about here, I have a demo data set. Yep, here. You can see here that this has a basic insert query, right? So insert into a demo table, values something, something, something. And here on the bottom, you have commit. This obviously only has 31 rows, but if you are serious about your database search engine, you obviously have more than 31 rows. You probably have billions of them. So if you insert data in this way, you have to be aware of the fact that your database will always save the changes. After every insert, it saves the changes. So if it would be a vanilla appliance, it would be one insert, then save the data, second insert, save the data, third insert, save the data, and stuff like that. But if you do, if you define an auto commit equals to 0 statement somewhere here, and then you do a commit statement underneath, this means that you're telling your database that it essentially should delay the saving of your data for as long as possible for the insert query to be as quick as possible. And in essence, all of the backup files, as you can see here, will most likely be defining indexes at the end of the insert operations and after everything is completed. And the reason why is because defining indexes in such a way is usually frequently faster than defining indexes in other ways. So what I will now like to showcase is your configuration file that you will need to be aware of. So configuration files are usually found in your server location. This is a local host, so this is WAMP. For Windows architecture, this will be most likely be in the bin location, and then you will need to choose what kind of a database management system you're using. So I'm using MariaDB, so I'm choosing MariaDB. Then you have the version, which is 10.10.2 for me. And then you have a bunch of files here. You will have a binary folder, you will have a data folder, and you will have a bunch of other files. What you're interested in is the bin folder and the data folder. The bin folder, in essence, it essentially contains every kind of application that MySQL and MariaDB works with. And the data folder, it contains all of the data within your database. So as I said, you will also see here ibdata1 file, right? So as I mentioned, this file, it's pretty large for me. It's 500 megabytes. So in MySQL, it essentially decided that making this file 500 megabytes in size is enough to account for my needs, enough to account for the local server. And in essence, it stored metadata in the file, and it made this file of 500 megabytes in size, and it stored all of the rest of the files in separate files. So you will see here the folders here are not there without a reason. They're there because they depict some sort of databases that you have. So for example, as you can see here, all of those things are databases for me. So if I, for example, go to admin database here, you will see that I have a bunch of files here. What those mean is that FRM files, they mean that this is the metadata from the table. MyD files, they tell you a lot as well, because MyD means that this table is based on MySam, which is why it's called MyI. D means data, which means that this table is called MyBB admin log, and it's called and it's based on the MySam storage engine. MyE means that in essence this table also has an indexes. So indexes and data is stored in separate files, as I already told you, and the rest of the metadata is stored in this file right here. This file should never be deleted, because if you delete this file, you will automatically get rid of everything inside of your database. And what I would now like to showcase is that you most likely in your use case, you will necessitate to connect to your database. So I'll do that now. And I'm connecting to a local instance. So I'm using an instance without a password. And once you're connected to database management system, what you can do is you can start evaluating your use case, right? So if your, for example, queries run slow, what you can do is you can, in essence, check on what kind of tables you have. So if we connect to a database and then see what kind of tables we have, we can see that, for example, for an e-commerce demo appliance, we have around 400,000 tables, 400,000 rows. Right, so you will also see that InnoDB tables, as if they have more rows than, let's say, 100,000 or something like that, you will not see an exact row count. And this is the problem that I told you earlier, that InnoDB does not store an exact row count inside of itself, so it cannot return exact row counts as MySam can. So for example, MySam tables, if you would have many of them, you would see exact row counts like here. And even if you would have millions or even billions of rows, you would also see an exact row count here. You won't be able to do that with InnoDB, but with InnoDB, you would be able to modify it so much more than you would be able to modify MySam. So to modify anything related to your database, you will have to, as I told you, to open up the configuration file, which is my.ini in Windows. This will be my.cnf in any kind of Linux appliance, and it will be most likely in the temporary folder or somewhere around that range. So one thing that I would like to note before we actually dig into these things is that Windows appliances will usually have so much more comments and so much more options that you will see, because MariaDB and MySQL decided that for Windows users, they're going to comment absolutely on everything that exists for some reason. Linux users don't have such a privilege. Linux users will only have usually options available to InnoDB. So this will be from, I think, here to here, somewhere around this range. So only these options. So if you open up your configuration file in Linux and you will see that it looks nothing like this, this is precisely the reason. Regardless of what options you see, all options mean something, right? So as I said, the buffer pool size, it in essence means how much of your operating memory, how much of your RAM you want to be accessible to MySQL or MariaDB, right? So this system I know has 16 gigabytes of RAM, right? So the reason why I put this at 1 gigabyte is that I'm also accounting for Windows architecture, right? So Windows architecture is usually more heavy on the on the file sizes part than Linux is. And MariaDB data file path, it's essentially defined the default file as 12 megabytes, and the maximum file size of that file is 500 megabytes, which would, if we check this here, you will see that there is, yeah, exactly 500 megabytes. So this is kind of the maximum. And what MySQL sets the file size to this size. And essentially, when your data gets bigger, when it overcomes the size, it increments the size by 12 megabytes, which is why it says auto extend, basically increment automatically. And file per table, as I already told you in the conference part of this tutorial, it essentially means that InnoDB saves all of the data pertaining to InnoDB in separate files. So the one more thing that I would like to showcase, we're running out of time pretty much, but one more thing that I would like to showcase is the power of explain queries. So you can see here that I'll have a bunch of tables that I will showcase this on a demo data table. You will see that if I inspect the structure, I have a bunch of indexes here. Actually, I have two indexes here. So a primary index and then a covering index that may be used for my query structure, right? So as you can see, I have a covering index called composite index, which means multi-column index, and it has multiple columns inside of it. So it has a username, gender, and country code columns. Obviously, this depends on your table structure, but this gets the point across. And if you see, for example, that you have big data sets, and if you have billions or millions of rows and your queries are slow, the first thing you need to do is not to modify the indexes or drop them or somehow work with them. The first thing you would need to do is you would need to run explain queries. So explain queries would be as simple as putting explain before your query itself. So you put explain and then the query. So for example, select all from demo data, where, let's say, what kind of data do we have? Okay, so usernames, where, these are all random usernames, by the way, this is all automatically generated. So if you insert your query here and you put an explain before that query, what you will see here is that MySQL will return all kinds of specific things that let you, in essence, understand how your query works and why it works that way. So this returns a select type, which can be either simple, either union, or something else. So if you use a union query, this will be union. If you don't, it will be most likely simple. It will also return the table that you run the query on, which is obviously demo data, which is, you can see here. Possible keys mean possible indexes. Keys are indexes in MySQL. This is a synonym. Possible keys mean indexes that MariaDB considered to use in your use case. Key means that the actual index that was used in your specific use case. These two columns can differ. And if they differ, you will actually need to readjust your query. So if you want your instance to use, if you want your query to use a specific kind of index, you will need your query to be structured that way. Key length means the index length. And extra, as I said, it can, as I said already in the presentation, it can have 4 or 5 different meanings. So in this case, it says using index condition, which means that using the index to access specific rows, basically. And there's a bunch of other specific things related to indexes. These things I covered in my indexing part of tutorials on SimpleTalk on Redgate. So if anyone's interested in, you can simply Google my name and Redgate and you will find these things. And here I explain indexes in a lot more detail. And obviously these things are also explained in a lot more detail in my book, which is available at hackingmysql.com. So thank you. I'm available to answer any questions you might have. We didn't go through a lot of the things in the workshop part of this tutorial, but that's just because we don't have enough time. If I would cover everything, I would be covering here for a week, probably, not for 1.5 hours. So thank you. I hope you enjoyed my talk. I hope you learned something new. I hope it was interesting to you. And I hope you enjoyed. If you did, I actually would like to ask one more thing from you. So I have a feedback form available on my website, which is if you go to my name, surname / feedback, I'll drop that in the chat in a moment. You will be redirected to a Google form that you can fill out to let me know how my workshop went. So if you would do that, I would be very appreciative if you did. If you don't want to do that, that's no stress. But I hope you enjoyed, and I hope you will search for your data if you're at risk using the database search engine at bridgedirectory.com. If you won't, well, I hope that this workshop helped you understand at least a little bit of how database search engines are run and operated and what consists in doing that. So thank you, and I'm available to answer questions right now. I'll stop sharing my screen and I will answer any questions that you might have. So if anyone has any questions, then let me know in the chat, or maybe hosts can let me know.
We have a couple of minutes, so if anyone have question, be free to ask.
Yeah, we have a couple of minutes here, so if anyone has any sort of questions, suggestions, anything like that, you can ask. And I already told you that I will leave a link to a feedback form. So this is not necessary to fill out, but if anyone of you would consider filling this out, this would actually help me a lot. And I would be very appreciative if you did. So I don't see any questions. So if you have any questions, you can always reach me via email. And I guess that would be it. Yeah, so thank you very much for having me, and I hope you learned something. I hope you enjoyed this presentation. So thank you.
Okay, so if nobody has a question, thank you, Lucas. It was very interesting. We enjoyed it. And thank you, everyone.